All right. My name is Sugu. I'm CTO at PlanetScale. I'm also the co-creator of the Vitess project, and I've been working on it since 2010 when we started it. So how many of you have heard of Vitess? How many of you don't know what Vitess is? So there are a few. Okay, cool. So Vitess is has been called by many names over the time. It's about 9 years old now. But the latest thing that we like to call it as is it's a cloud native database. The reason is because Kubernetes is gaining popularity, and like it or not, Vitess runs really well in Kubernetes. So that is now extremely relevant. So therefore, the first property of Vitess is that it's a cloud native database. But it did run at YouTube. So it is massively scalable into like tens of thousands of nodes, and high available, typically running 5 nines of availability is pretty comfortable for Vitess. It's not something that it struggles with. And the best of all is that it's based on MySQL, which means that if you are familiar with MySQL, if you already have data in MySQL, then it's extremely easy to migrate to Vitess. But the best news is Vitess recently graduated as a CNCF project, which is super awesome because it's the 8th project to graduate, which means that it is now on par with projects like Kubernetes and stuff. So it has great visibility and good recognition, because when they go inside a project, they actually look deep inside to make sure that it is a healthy project, that it actually has all the processes, tests, and everything. And CNCF agreeing to graduate Vitess means that it is considered a high quality and well adopted project. These are some of the stats, but the coolest one is by far what kind of customers we have, right? What kind of users use Vitess, and the type of users that use Vitess are actually the cool companies. The cool kids use Vitess, like Slack and JD.com, Pinterest, GitHub. So these are names everybody knows. These are companies that are more or less dictating the future of where technology is moving. So it's cool that they are putting their name behind Vitess, which gives it the credibility, and that invites more adopters to Vitess. So that's something that we are very extremely proud of. And I'll actually cover some of the use cases in here. So before that, I want to start with where we started. In 2010, at YouTube, we were very happy with our infrastructure, kind of like this dog, but yes, things were like falling apart like anything. Like every day, 2 or 3 outages, and every time it was always the database. There's an outage, people just call the database people, see, hey, there's an outage, it must be the database. It became almost a synonym. So at some point of time, my colleague Mike and I kind of said, we need to do something about this. So we pulled ourselves out of day-to-day operation, and we built a spreadsheet with every possible problem we had ever faced, and every possible problem we are likely to face. And we listed all the solutions, and then when you looked at everything, it was obvious that we needed to build something, and that's essentially how Vitess was born. And so we built initially a proxy layer, a connection pool, we deployed it, and it ran well, and everybody was happy until about 2013. So in 2013, this guy happened. I don't know how many of you recognize him, Snowden. He lives in the neighborhood somewhere, I heard. So when this happened, until then, YouTube data was actually in YouTube's own data centers. And Google said, you can't do that anymore. You need to move all the data out of the data centers into Google's own data centers. So we had to migrate inside Google, Google's cloud environment called Borg. How many of you have not heard about Borg? Okay, some of you have heard of Borg. Okay, cool. So Google has its cloud environment. It's an entire ecosystem with its own APIs, its own tooling. Everything is custom, everything is internal. And they said, we needed to move our YouTube's data, which was running in MySQL, sharded MySQL using Vitess, into Google's Borg cloud. So we had to make some tough decisions. And there were two really, really difficult decisions we had to make. One is, if you are going to move to such a proprietary API, and at that time, Vitess was an open source project, how do we keep this project open source was one big challenge. And the other one is, how do we even run in Borg? Because the rules are different. Borg is a cloud environment and very, very hostile to especially stateful applications. So the first problem we solved by saying, so we were like, the pressure was clearly forget open source, just make it custom, make it work at Google. We refused to do that. We said, we are going to keep it open source and we are going to see how far we can go. So we built all kinds of abstraction layers to make sure that Vitess remained open source. But the real hard problem was, how do we run inside Google? The one thing, fortunately, we didn't realize was that all the storage systems inside Google are actually provided as a part of the infrastructure, kind of as if Borg itself gave you that storage. So we didn't know that. And we said, well, what are the rules of running something in Borg? And Borg actually allowed you only to run your stateless applications inside its environment. So we ported Vitess inside Borg as if it was a stateless application. So that means that Borg, it'll like, at some point of time, it'll think, okay, this process needs to be scheduled. It will like take your process down. It could be your master database and wipe all your data. So that's what Borg does to stateless applications. It assumes that you don't have any local storage, or any local storage that you have is unimportant. So that's the kind of environment we had to make Vitess run. So we had to build some durability features, that would survive this type of takedown. So what that means is, so like, what do you call a storage engine running as a stateless application? It's called stateless storage. That's our new term for Vitess. So all of this culminated in 2015 when Kubernetes came out. Said, we are ready for Kubernetes because we can run on Borg. We don't care if pods get taken down. We don't care if data gets wiped. We know how to survive those things because that's what we made Vitess do. So in fact, Vitess was ready for Kubernetes before the first line of Kubernetes code was even written, which is kind of super exciting. And you can see we published this blog post before Kubernetes 1.0 even came out. So as soon as Kubernetes was announced, we said, we are ready for Kubernetes, let's publish the blog post. So we did this, and people believed us. And this company called Stitch Labs, they were having trouble with their sharding environment. They said, hey, can your software run on Kubernetes? I said, yeah, of course. Just use it. So they started using it. In 2016, they went into production, and they are still in production. So by far, Stitch Labs has the record of the longest running Vitess instance in Kubernetes. Then company like HubSpot came. Stitch Labs is actually a small startup. It's a startup company that is you might not have heard of Stitch Labs, but they run huge QPS. So that's another thing about the new data thing is even small companies have huge data, have huge QPS. It's because storage is cheap nowadays. Then HubSpot came and they said, we need a place, we need a system, a procurement system for databases. And that's basically what they wanted to build. They said, we are not interested in Vitess's sharding features. We are interested more in the cluster management. We want to be able to bring up clusters, handle reparents, and all those things. And they said, we want to use Vitess for it. And they deployed like hundreds of key spaces or databases in Vitess. And they have an automated system for that. So they did that. And that was successful, all on Kubernetes. And then finally, JD.com didn't even tell us. They just quietly learned Vitess, quietly deployed it into just tens of thousands of nodes. Like they have like 4,000 key spaces, all on Kubernetes. And then they come and tell us, hey, we are the second largest portal in China, and we have deployed Vitess everywhere. So it was kind of pretty exciting. And then we met their VP of engineering and kind of collaborated on this. And the last story, which is on Nozzle, is this Nozzle company is a startup and you know what startups do, right? They go for looking for free credits in various public clouds. So they say, I'm a startup, can you give me free credits? So Microsoft gave them free credit. So they deployed on AKS. They deployed Vitess on AKS, and they used all the credits. And after some time, what happens to credits? They finish. So they said, okay, GKE, do you have any free credits for me? And GKE gave them free credits. 1 hour, they were out of Microsoft into Google's cloud, completely migrated. And why could they do it? Is because they were 100% on Kubernetes. So being in Kubernetes, end-to-end, gives you this great flexibility where you can tell a cloud provider, hey, you don't give me a good deal, I'll just go next door. But if you are locked into RDS or Aurora or Cloud SQL, then you can't move like that, right? So this is another big advantage of using Vitess inside your Kubernetes environment, because you can like pack your bags and move anytime you like. So these are some of the stories that we have. So Vitess has been running stateful workloads in Kubernetes for forever, ever since Kubernetes is born. At the same time, then we suddenly realized, like, Kelsey, I don't know how many of you have heard of Kelsey Hightower? Okay, Kelsey Hightower is a well-known person, evangelist of Kubernetes. He says something, everybody listens. He hosts KubeCon, and he is very well known. He tweets and everybody jumps. Look at the number of likes, right? Within a few hours of him posting, 914 likes. So he says, you should not run stateful workloads in Kubernetes. You're going to regret it. You're definitely. And I'm like, Kelsey, look at Vitess. It's running so many stateful workloads. Don't tell people not to run these things. But to his point, there is a reason why he says that. He says that because Kubernetes is a ruthless environment. If you just took your MySQL and put it in Kubernetes, you will regret it. You will lose your data, or you will lose uptime. Because once Kubernetes takes on your pod, how are you going to make sure that you don't lose your data? So you have to do something about that. And the other one is, even if you used a PD or a EBS or a persistent volume, it takes down your master. You need to wait for your master to come back up, right? So one of those things you have to pay for. So he basically says, unless you know how to do this, don't do it. But then after much education, now he has changed his point of view. Now he says, don't move your data into Kubernetes by yourself, but you can use some systems are ready to help you move. He talks about CockroachDB and Vitess. So sometime in 2016-15, okay, this is Russia. How many of you have heard of Slack? Okay, how many of you do not know what Slack is? There is someone who does not know what Slack is. Okay, yes, Slack is actually one of the fastest growing companies of the Bay Area. It's actually one of the most respected. They've achieved, you can look at their growth graph. They are really, really exploding. And they had trouble keeping up with their databases. So they invited me to see whether they can adopt Vitess. And their main thing was, should we build something ourselves or should we buy from somebody else? So I went and told them, why not both? You buy into Vitess, and then you build what you want inside Vitess. So you have a nice base to start off with, and then if you wanted any features, they bought that story. They said, I think that's a good idea. So they adopted Vitess, and you can see their graph is, the blue line is the Vitess line, slowly catching up to their full traffic. They are now about 35% migrated, doing about 500,000 QPS, which is actually, it's not very big. Vitess can handle much larger QPS, but this is what they do. And best of all, look at their latency, like 1 millisecond of added latency as overhead for Vitess. And this is what what Slack has to say about Vitess. They are saying there is no other bet we are making in terms of storage for the foreseeable future. So this shows the extent to which Vitess can be trusted. And this is not just Slack. Like every company that has committed to Vitess, they are not interested in moving anything else. They are so happy. Square Cache actually, they worked on a project to do Vitess sharding. They finally split their main database into 2 shards, and their first statement was, "We are finally stuck with Vitess. We can't migrate out anymore." And then now they are at like 64 shards or something. What used to be one database. So this is the Vitess architecture. And this actually is an explanation, this I can use to explain why Vitess is cloud native. So people say, no, oh, I am cloud native. I am cloud native. If somebody asked you, why are you cloud native? Can you answer why, right? There has to be a reason why you have to call yourself cloud native. So in Vitess's case, let me explain how it works, then I'll explain why it's cloud native. So there are actually 2 layers. There is the VT gate layer, which is a stateless proxy, and you can roll out as many VT gates as you want as you need. Applications can connect to any VT gate, and that VT gate will speak the MySQL protocol, and it will look as if that the application thinks that it is connected to a single MySQL server. But under the covers, there is this whole farm of MySQL and VT tablet pairs that are running, and VTGate just directs traffic to them. And what these VT tablets do is whenever they come up, they actually register themselves with this topology, and the topology is what the VT gates use to discover them. So it's a system, and so there's basically 3 principles here. Simplicity, just a 2-layer architecture, which is absolutely necessary to run in Kubernetes, and I'll explain why. Loose coupling, which means that all these pieces, they more or less operate on their own. So the whole, it is very hard to design a scalable system that is loosely coupled, and I think that is one of the greatest achievements of Vitess. This means that once you have loose coupling, you can just scale out pretty much indefinitely. So that is the advantage of loose coupling. And the third one is survivability, which means that we don't depend on any one particular piece being up. Any piece can go down. There's always another piece that is there to take its place. So that is the whole principle behind this Vitess, and that is how this is designed. So in particular, with respect to Kubernetes itself, if, for example, a master pod is taken down by Kubernetes, right? Kubernetes takes down your master pod. There is nothing in Kubernetes where you can go and say, oh, designate that other thing as master. There is no API, there is no mechanism in Kubernetes to be able to say that. And that is the reason why you need a proxy layer to be able to react to that change. If the app was directly connected to this VT tablet, then if that goes down, you're going to see downtime until the app itself has to have a way to figure out, which means that the app needs to discover what is going on, which is not the app's job, right? So we have this middle layer that does that. So that is one thing that makes it cloud native. And the other one that makes it cloud native is that when this pod gets taken down, how do you make sure you don't lose data, right? So that is the other part of Vitess that makes it cloud native. And there is actually a third part which is more subtle. Vitess encourages small instances. Like you don't, if you run your data in Vitess, you don't run terabyte size or multi-terabyte size nodes. Each node is only like a couple of 100 gigs. So the idea is that if something goes down, we immediately bring up another cluster. It takes only a few minutes to restore from backup, and then after that you're up and running. Right? And the reason why we can do that is because Vitess can shard. So if you can shard, you don't need to have these huge terabyte size instances, which helps you scale pretty much indefinitely and survive in an environment, in a cloud environment like Kubernetes. So does this make sense so far? Cool. Now it's demo time. So we are going to reserve questions for the end. So I actually have taken screenshots of this demo, but I'm going to try and do it live. It's always more fun if you do it live. So here is a use case. Let's assume that we are building a marketplace. There's a customer table, there are customers who want to buy products, and there are merchants that are selling those products, right? Very simple schema, right? Very straightforward. So which means that you need an orders table, and the orders table has foreign keys. Like there's a foreign key to the customer of who orders it, there's a foreign key to the product of what product they bought, and the foreign key to the merchant who they bought it from, right? So this is very easy to deploy in MySQL. But let's say you suddenly have a billion customers, lots and lots of merchants, billions of orders. How do you shard the system? Do you, more particularly, this orders table, how do you make sure that, where do you put the order table, right? Do you put it with customer or do you put it with merchant? So those are difficult questions to answer. The answer is, there is no right answer. The answer is very dependent on your workload. And even if your workload, sometimes no matter what workload it is, you may not have the right answer, right? So this is a difficult problem. And this is something many of Vitess users face. And we have figured out a way to solve this problem. It's seemingly impossible, right? Because the moment you decide that orders is going to live with customer, you've also decided that it's not going to live with the merchant. But then what if a merchant comes and says, I want to see all my orders? So you have to go all over the place to hunt for it. So I'm going to show you a Vitess cluster that actually models this. So the way we have sharded this is that the product database is unsharded, which means that there is only one instance. The customer database is sharded. I've made a decision that orders are going to be with customer. So let's assume 2 shards per customer. And a merchant database, which is sharded on its own because merchant has their own key. And that is what the merchants do. So I have about 18 minutes to finish this demo. Let's see if I can do it as fast. OK. So I have already brought up the cluster. I'm going to. So let's assume this is our e-commerce application. This is your portal where customers place an order. The only difference is, if you imagine you're a customer, you figure out when you create yourself, you figure out what statement that results in the database, and you type the statement. And then it'll create. You have to pretend that you're a customer, but then you actually just type SQL. So it's kind of a geeky way of, this is the portal for geeks, So here is a completely empty database. So I'm going to populate it in the interest of time. So I have some data here. So here is a bunch of insert statements that pre-populate the data. It inserts some rows into all the tables. So I'm going to run my MySQL client. OK, and let's refresh it. It's populated. This app, what it does is it actually highlights in red color anything that is new, that is from the previous screen. So you saw that I just gave some simple insert statements, but the rows went all over the place. Right? It's because based on sharding rules. So the values I chose are meant to show that things go in different places, right? When I say insert, I didn't talk about key space, I didn't talk about database name, I didn't talk about shard, I just gave values, but they went to different places. So that is one ability of Vitess, which is transparent sharding. When you are talking to Vitess, you don't have to worry about where your data goes. Vitess manages that for you. And how that management happens is a separate talk, which I will not cover today. So you can go and say, I want to run a query called, I want to select all products, right? If you run a select all products, it says, oh, product, I know where product is. Product is in the product key space. So I'm going to execute a query, send this query to product, and then the results are shown. So if I say select star from customer, the customer is actually a sharded database, which means that it has to send the query to all customer shards. So it sends one query to the -80 star shard and one query to the 80 star. Don't worry about limit 10,001. That's a protection feature. We can talk about that maybe offline if you are curious. So it says that I'm going to gather the data. These are simple queries, right? Anybody, any system can do this. Let's up the game. Let's build a more complex query. So this query is saying I want to select the customers and their orders joined together, right? So this sharding scheme, I have figured out a way to tell Vitess that the customer's orders stay with their customers. What that means is that when I go to a customer shard, their orders are with them, which means that this join does not go cross-shard, even though it goes across shards. So that is something Vitess can figure out. If I run this query, it just sends that query unmodified to each shard, gets the results, and just returns them directly. Right? So straightforward, intuitive up to this point. Now let's up the game even more. How about this one? So this query, if I had time, I'll go into all the where clauses and stuff, but I have only about 15 minutes, so I'll explain the query at a high level. This query, basically what it says is, find out all the customers, join with their orders, and for each of the order, find out the description of the product. But the description of the product is actually in a different key space. So what that means is that how do you even make this query work, right? The brain dead way of making this work is join customer with orders, get all the rows, just like the previous query. But for each of those rows, send a query to product and say, give me the product description for each of those rows, which is exactly what Vitess does for you. You can see here that it selected the first part of the join, sent it to the customer database, and for each row that it returned, it sent a round trip to the product table to fetch the description. So yes, it works. Kind of painful, right? Like imagine doing this for 1 million customers. So what's the right, how do you solve this problem? The product table is a small table. What if you could copy that product table into each of the shards? Then everything is a local join, right? So Vitess allows you to do that. It is called a reference table. You can say that I want to create a reference table called product inside my customer database, but I want that reference table to be materialized from the product key space. So the command to do that is, let me do it here. Oops. I have them all typed in my README file. And this is all in my open source, so you can actually try this demo yourself. So I say, please materialize the product table into the customer's key space. Also create the table, and it is a reference table. So the moment you say that it's a reference table, it doesn't shard it. It materializes the full table into each of the shards. And now let's do a refresh. The table has appeared. But if I repeat that query, it's not going to do anything different. The reason is because I haven't given metadata that these two tables are the same, so all that thing we have to tell Vitess, right? And also, if a materialization is going to take a long time, you have to give it time for it to catch up. So it's done in 2 phases. First do the materialize, wait for it to materialize. After it has materialized, you say externalize, right? So, which is the next command. As soon as you've externalized, and then let me repeat this query now. Now the query has changed. All it did was send the entire query to each of the shards because it joins locally with the product table. So now we have made this query extremely efficient. Okay, how about, there's one more thing. Now what if I go and insert a product into the product table? I'm going to do that. As soon as you insert a product into the product table, that immediately gets materialized into the target tables. So the way we do this is by actually subscribing to the min logs, and just like MySQL replication, it just keeps it up to date. It's eventually consistent, but it still works for you. So you have to know that when you're writing your program. Okay, how about this query now? Merchant saying, okay, you made your customers happy, but make me happy, you know. I want to see all my orders, right? And merchant seeing their orders is query from hell, because select star from merchant is going to be a cross-shard query across all merchants. But for each of the rows that come, I have to send a scatter query because a merchant's order can be any customer shard. So it's an M by N scatter, which is enormously huge in terms of complexity and time taken to execute. So, but then I cannot take, the orders are billions of rows, I cannot materialize all the orders into one shard. But then I don't need to, right? I only need to materialize the orders that are relevant to each merchant, right? If monoprice, if an order belongs to a new egg, that order does not need to be in the monoprice shard, and vice versa. So you can tell Vitess to do that type of materialization. So I'm going to do that for you quickly. And ta-da. Let's refresh. Materialized. So magic commands, but they are like DDL. No? You issue like DDL. Please materialize this table using the following rules. There is a formal way to describe what this means. And once you do that, it does it for you. And now if I rerun that same query, which was going all over the place, it now is a simple query. Just send it to all shards, gather the results, and return. Now, let's do something crazy. What if I did this, right? I'm going to change one of the orders that used to be with monoprice and change it to new egg. If you do that, it gets updated here, and the row actually migrates from one shard to another. So Vitess is capable of handling pretty complex changes in the source and keeping the materialized view actually consistent with respect to the rules specified on the target. So the last part of the demo, which is boss comes and says, yeah, this is all fine, but I want real-time data on my sales figures. No? I want to keep up with sales up to the millisecond. No? How do you do that? So the secret that I've held out until the end is that this materialized view can be expressed as a select statement. It's not just say materialize this table using this following rules. It's materialize table using the following select statement. And if you can specify a select statement, you can also specify aggregation rules. You can say select ID, comma, count star, comma, sum, comma, this, and all that. And it will actually materialize for you, and it will keep that up to date, right? So that comes to the last part of my demo, which is I'm creating the target table, which is my sales table. And I'm saying materialize it using the following rules. You can see here the select statement. This is my materialization expression, right? Group by PID. This is basically as if you ran this query on the source, except that this query is now continuously applied into your target database from which you can query from. So instead of querying from the source, you just do a select star from the target. And I'm going to externalize, which is command here. All right, let's see if it worked. And the sales figure appeared here. Now if you can run some queries on sales, and it will return the results. And if you change if you add an order, like here's, for example, I'm going to add an order. Watch, this is PID is 1, which means that watch the first row on sales. As soon as I create a new order, you can see that the materialization actually has gone from customer to merchant as well as to sales. Because in one case, it materialized the row. In the other case, it actually aggregated the results for you to keep track of in the future. So that is perfect. Somebody said I have to finish in 35 minutes. I'm almost there. So these are the reason why I wanted to show this is because one problem with sharding is we encourage you to shard. We encourage you to split your data into smaller pieces. But then the thing is, I don't want to shard the data because I want the data to be together. But if you want the data to be together, you can use vReplication, which is a core technology inside Vitess, to keep them together while at the same time keep it sharded. So that is a huge deal for those who want to go to the cloud, run small instances in a sharded fashion. So it's extremely important. All right. So back to so this materialization actually works for a large number of use cases, not just materialized views. You can do real-time roll-ups. Those are the 2 use cases that I showed you. You can migrate tables from one place to another because it's essentially materialization followed by changing your write traffic, what you write to. You can subscribe to Vitess and say, just show me all the, give me all the changes because I want to feed into another system. You can use it for data migration. Like you say, you bring up a Vitess cluster and you say, point it at MySQL, I want to migrate all the data into Vitess. Vitess can do that for you. It's actually, the feature is being built. Slack is actually building that feature, so it'll be ready extremely soon. They are going to use it for their own purpose. You can use it for schema deployment. How many of you have heard of Ghost? Alkin knows. Halkin has heard of Ghost. He probably knows a little too much about it. It's a tool that MySQL users use, developed by my great friend Shlomi Noach. So vReplication can also do that functionality. And backfilling of lookup indexes, it probably means nothing to you, but it's a great feature is all I can say for now. Yeah, and what to do next? Go to vitess.io, check it out. There is a tutorial there. Go through the tutorial. It kind of walks you through some of these use cases. Join the Vitess Slack. We are a very friendly and inclusive environment. You can feel free to ask questions. My company, PlanetScale.com, was built to help Vitess adoption. And we have actually now built a Vitess as a service. You can go to console.planetscale.com, click a few buttons, and bring up a full Vitess cluster that you can play with. As long as it's not too big, it's free for you to play with. But then if you want to go enterprise and do stuff, then there is a paid version of it later. And so, yeah, so bring up a cluster with that. Any questions?
Sugu?
There are awards for questions.
Thanks for your speech, Sugu. That was great. It's for you. Does anyone have questions?
All right. Yay.
Okay, thanks for the talk. You mentioned in the first part that, and I don't know much about Kubernetes, but you mentioned this concept where you can lose a pod and you lose all your databases and how to survive that. So why do you deploy a replication cluster in the same pod or something? Don't you have a concept like availability zones or regions where you could have different MySQL nodes so that one of them would be expected to survive?
So Kubernetes has this feature called, it is called anti-affinity. Right. So you can give anti-affinity rules and say that master and replica should not be co-located. And Kubernetes actually takes care of that. And I don't know the exact details of how you configure it. But I do know that in Amazon, there are availability zones. And it is easy to configure saying that I need anti-affinity rules across zones. And then if you lose a zone, then you don't lose your data. So that coupled with MySQL semi-sync replication, which ensures that a master commit is not complete, at least one other replica has the data, is pretty much what we used at YouTube to ensure that we never lost data. Okay. So that is, yeah, good question.
Кто-нибудь еще хочет задать вопрос?
Any other questions? Yes.
Thank you for great talk. I have a question. Could you please explain how materialized views work on remote node? As far as I understand, you create materialized view from one node to another. And how do you track the updates? Do you use binary logs or how materialized views propagated to another node?
I didn't. How do you do materialized views across remote?
Yeah, across remote nodes.
Oh, that is, so the way materialized view works is just like MySQL replication. So what it does is it actually, just like MySQL can replicate across the world, it's eventually consistent. So which means that there is a delay depending on how far the node is. So if it is like across the world, it's going to be about 1 second behind.
So you use asynchronous replication.
Correct. So the way it works is Vitess actually subscribes to the bin log and says, and basically lies to MySQL saying, I'm a replica, please give me your bin log. And so the master gives you the bin log, but then Vitess takes the bin log, transforms it based on those rules that I mentioned, and applies it on the target.
Okay. How do you track consistency between the nodes? So if you have a time lag between the first and the materialized view, if instantly the first replica shuts down in a Kubernetes cluster, and if you run query on the materialized views, then you can typically lose some data if you use synchronous replication. So I would imagine that you should use synchronous replication like Galera or MySQL synchronous replication.
Cool, yeah. So the MySQL guarantees that there will be no data loss. There will only be delay in your data being copied. So if a node goes down, the application of the events is transactionally consistent, which means that it always knows the position and the value of what was last applied. And if a node goes down, it can go to another node and say, I want to resume from the last position where I lost the connection, and it will continue from that point on. So you will never have inconsistent data or incorrect data, but you may have delayed data, which means that if there is a network partition, then it may take time for the event to catch up, but it will never go inconsistent. It will only be delayed. And in order to, there is actually, Vitess exports statistics, continuously real-time statistics about how far the delay is. So it will say, okay, the delay is now 5 seconds, or the delay is now 10 seconds. And you can set alerts and thresholds saying that if the delay falls too much behind, alert someone and say, hey, this delay is causing problem, go look at your network, see if there is an issue. So those features are available. But if there is a network partition, it is going to pause replication. So that is a trade-off that you have to live with for materialized views. Does that answer your question?
Yeah, I will ask more questions later.
Okay.
Thank you.
Okay.
Может быть, у кого-то еще есть вопросы?
There's a question there.
Отлично.
Okay, thank you very much for your talk. And I have a question about the reference tables. Yeah, so basically you said that this reference table will be contained in the copy of the data across the shards and like will be treated as the local one. So I have a question, like what will happen when the actual place where this table was saved will go down? So like on some other shard, we will see the copy of like the last accessed like this reference table, or we'll get an error, or like what will happen?
Okay. So the high-level answer to this is typically you are supposed to configure Vitess in this high availability mode, which means that you are supposed to have a master and multiple replicas. And the replication can be from any replica. It doesn't have to be the master. So that is one advantage, which means that if a replica goes down, Vitess will immediately find another replica and start continuing. But if, like I said, if there is a network partition, it doesn't matter because you're not going to get data. So in that case, whatever was copied, it will stay at that point. As soon as the partition goes away, it will resume from where it left off and catch up.
Okay, great, thank you.
Yeah. And there is one cool feature that vReplication does that even MySQL doesn't do, is if it is way behind, if it is like hours behind, it will just batch the transactions together. And so it can catch up extremely quickly.
Yeah, great, thank you very much.
Может быть, у кого-то еще остались вопросы? У нас есть время на один короткий вопросик. Окей.
No other questions? All right. I'm supposed to give out some awards.
Yeah, you have a mission.
I have a mission.
You must choose the 2 best questions.
Two
and
best
we'll
questions.
give them our prizes.
Okay.
Yeah.
The best question goes to you.
Прошу, выходите к нам на сцену, представьтесь, расскажите немного о своей работе и почему вы задали такой вопрос.
Yay.
Без разницы, хотите на английском?
Hi, I'll speak in English. Alexander, Tempest Technologies. We do some database work for MariaDB, for Pecona, and that's all.
Cool.
Yeah. So, thank you.
Thank you.
Just wondered why you don't use synchronous replication. I would suppose that it's better to use synchronous replication and not to lose data in network partitioning. This thing which I want to discuss you.
Definitely, we can talk about it. Yeah.
Afterwards.
Yeah.
Thank you.
Thank you.
Okay, thank you.
At the SRE book. All right. Thank you. And the next one goes to Enrique, who asked the Kubernetes availability question.
Вам тоже можно спросить.
Sorry, what am I supposed to say?
Your name?
Okay, I'm Henrik Ingo. I've been speaking at HighLoad. This is my 5th time, so my talk is at 3 o'clock today. I work for MongoDB. Did I say I'm from Helsinki? Yeah, so this is kind of close, and I like coming here. Nice to see all of you.
Thank
And thanks for this talk. I've been waiting many years to hear about Vitess, and finally I did it.
Cool. Thank you. Cool. Yeah.